that always one of the inputs connected to the 1 volt. That this 1 volt will be your control signal. So this go to the control signal. And connected to this, and then the other inputs will be B. B1, B0, B1, B2, and B3. And then we need to also add 1. So this control signal, if this control signal go to C in, it works like adding 1 to this number. So now look at this circuit. When you wanna check this circuit, if you put K as 0, the C in will be 0, and then all the inputs of the XOR will be 0. So if one of them will be 0, the input goes to the output without any change. So the B goes here, goes here, and then you have a summation. If you want to subtract, put the K as 1, means 2.5 volt. Then this will be 1, this one, and then all the inputs of the XOR will be 1. So it goes to these conditions, and the input will be converted. So the B naught comes here, B naught, B naught, B naught, and then added to the A. So this is the structure that you need to do for a 4-bit adder. So you use a schematic and the layout. And then the last circuit that you need to design is a 4-bit adder test bench. 4-bit adder test bench. So after you design this, you need to put this circuit, make a symbol of that circuit, and then put it there. Put 4 inputs for A, 4 inputs for B, B, A, and then 1 control signal, one C out, and 4 output. Out 1 and out 4. And then run the circuit and show me the result. So these are all the circuits that you need. You need to design 5 circuits. That these 3 circuit is in the website that I put it for you on the project 3 PDF. This circuit will be this one that you need this design, and this is also only the test bench that you will run it for check the circuit. So based on the project 4, project 3, if I go through that, so we designed the schematic of the circuit, that schematic from the website, draw the layout of all of them, show the DRC and LVS only for the 1-bit adder and 4-bit adder. Then the summation of these numbers. How we can do the summation? For example, you want to do the 2 plus 3. So the 2 will be 0. Look, the 2 will be 0, 0, 1, 0. The 3 will be 0, 0, 1, 1. So you will put these numbers here. B0 will be 0, B1, 1, 0, 0. How you can do that? You need to put VDC, DC voltage for all of them. So put DC voltage for all of them. If it's 0 means 0 volts. If it's 1 means 2.5. So put 2.5 for example for B1 and connect these 4 input for DC inputs to the B. And then for A also same story. Put 4 VDC, 4 voltage. And then you have a control signal. The control signal also will be put a VDC again. If you want to do the summation, for example, this will be summation. So you will put the 0 volt for the control signal. And then you have 4 output that will be 5. So that, and the output you must get 1, 0, 1, 0. Then if the second one, for example, is a subtraction, 13 minus 9. So for the subtraction, again put 13 here, for example 13 for the A, and then 5 for the second number, B, and then control signal must be 1 now, means 2.5 volt. This is the condition that you need to do. So do it for these 5 conditions and show me and take a screenshot of the output. Then the last part is a run post layout of all of them. Run the post layout for all of these conditions. Means run the post layout of the 4-bit adder, the last one, and then show me the result. And this is the link that you can use it for this project. So at the end, when you finalize that, this project has a demonstration. You will come to my office at the date that you can set the date on the data, Excel sheet that I shared with you on the announcement. So you can set the time and then you can come to my office. First, I will check your report. The report is not important. It's only 20%, like, or 10%. The only thing that I will check the result. So I check all the results from that, see that the result is okay or not. So you must have the introduction theory and everything. But but don't waste your time. Only like a short introduction, short theory. Don't put a lot of time on the report. So I will check that, and then if everything goes well, I will ask you to run some of these in front of me. For example, I will ask you run 2 plus 3 in front of me. So you will run that, and I will check your result and then grade you. And then after that, we have 3 questions. I will ask you 3 questions, technical questions, about the layout that you design, about your design. You know, like for example, I will ask you, okay, where is your explain your layout, explain your schematic, explain your DRC errors, find that. And then based on the 3 questions, and I found that you know the design that you already designed it with the Cadence, I will grade you based on the questions and also the result that you show me. So this project is completely related to your demonstration and presentation, and the report and everything will be only 10% or 20%. So be ready for this project, like multiple times run the outputs to know how to run the circuit, and then in front of me run this circuit. And you cannot change anything when you come to my office if your circuit doesn't work, it has a technical issues, for example errors. You cannot fix the error and then run it again. So remember that, check everything before the demonstration day. Okay.
How long will it take?
Only 10 minutes. Yeah, only 10 minutes. You will run, like for example, 2 of these, and then maybe your post layout. I will ask you about the post layout running, and then some questions, 2 questions. So 10 minutes is enough for this presentation. Yeah, that's it. Do you have any other questions? Okay, from now, the project will be 35% of your final grade. Before that, the project 1 and 2 was 15% of your final grade. Now this will be 35. Project 3 and project 4 together will be 35. So now it's better to spend more time on this project because it has a lot of points. Okay, if you don't have any questions, we can, the class is over. If you have any issues on the design, you can show me that you're